Hi everyone, my name is Kyosuke Nishida. Today I will talk about Tsuzumi. I will introduce a demonstration where Tsuzumi answers a question about itself. This is the actual output generated by Tsuzumi, a large language model developed by NTT. As you can see, Tsuzumi can respond to the question accurately and quickly. So with the parameter size of 7 billion, it is relatively small compared to other models. And it supports both English and Japanese. Oh, sorry. And we enhance its capabilities, especially in modalities. We look at the features of Tsuzumi. Our model is inspired by the traditional Japanese musical instrument of the same name, Tsuzumi. Our model has advantages in understanding and generating Japanese. This is a capability not found in most open models, such as Llama 2. Second, our model is lightweight, yet powerful, similar to the Japanese drum that is small in size, but has a strong impact. Last, our model has much modality. Tsuzumi, the Japanese drum, looks, sounds, and acts beautifully. Tsuzumi handles various types of data effectively. Now let's move on to the first feature of Tsuzumi. We have implemented the concept of AI constellation for a sustainable society, shifting away from the heavy reliance on large monolithic models that require significant computing resources. We focused on resolving societal challenges through the collective intelligence of smaller, efficient AIs. Using NTT's network, IWON, we harness a constellation of specialized AI to facilitate sustainable solutions. This is a demonstration in Japanese where we have Tsuzumi and GPT 3.5 discuss Japanese policy. So it is evident that Tsuzumi generates text very fast, significantly faster than GPT 3.5. Why fast is the generation so fast? The first reason is its parameter size and quantization. We have developed over 2 types of lightweight models. One has 7 billion, and the other has 0.6 billion parameters. They are significantly smaller than recent huge models, such as GPT-3, that has 175 billion parameters. Both can operate on a single GPU, and the smallest version is capable of running on CPUs. Additionally, lower bit quantization of parameters enhances speed and reduces memory load. For example, an 8-bit version runs efficiently on a GPU with limited memory. The second reason for the speed is our tokenization process. Our tokenizer has a compact vocabulary with a robust selection of Japanese tokens, achieved by minimizing redundant tokens through word segmentation constraints. For instance, GPT 3.5 tokenizer, which is not specifically focused on Japanese, results in less efficient and produces many character and byte level tokens. In contrast, our tokenizer, which is focused on Japanese and uses Japanese grammatical knowledge. This is more efficient compared to GPT's tokenizer. Our tokenization reflects natural Japanese structure due to word constraints we used. So now let's move on to the second feature. It's proficiency in Japanese. We introduced the benchmark results for Japanese language models called Rakuda. Our model outperformed GPT 3.5 and other Japanese models such as Kamatsu, Eliza, and Rina in the benchmark. It has seen a 30% increase in win rate against GPT 3.5 since October. This result was achieved by pre-training on over 1 trillion tokens and fine-tuning with our high-quality instruction tuning corpus. Here is an example of question answering and assessment in Rakuda, demonstrating how two models responding to the questions, testing their knowledge of Japan. This question is about the social and political changes in Japan. GPT-4 judges which of the two outputs is better. In this case, Tsuzumi was judged better because it provided more specific and detailed responses. Tsuzumi is also capable of answering questions in English. So I will show you some examples. First, as a brainstorming task, I asked Tsuzumi how AI changed our lives. Next, we asked it to extract the information from the previous response. Then we asked it to draft an email requesting collaboration with a medical doctor. And finally, we asked it to express its opinion on the futures of AI using emojis. From the responses, it is evident Tsuzumi can respond to the question in English as well as Japanese. The final feature of Tsuzumi is about multimodality. Since around 2020, we have been enhancing our language models with a visual comprehension component, enabling the model to understand document visually. We propose a visual document understanding model, which consists of an image encoder, a language model, and an adapter for visual document understanding. In this case, our model was able to understand the table from images and output the correct answer. Our paper on this adapter was presented at AAAI, which is a top conference in AI. This is an example of information extraction from an order form. We asked Tsuzumi to convert this image into JSON format with the keys of name, phone, and message. Sorry. We can say from the results that Tsuzumi was able to extract the information as instructed from image. This capability is useful for digital transformation powered by language models. The next one is example of question answering on the document. Tsuzumi was able to answer the question based on the visual content. This capability is useful for retrieval augmented generation using visual information. Finally, I will explain our vision for the future. Our goal is to create an AGI that can naturally coexist with people in any environment and achieve humans' well-being. We aim to develop a software robot that can work with humans as a collaborator on a computer. And we develop a robot that grows with people as a life partner. Such AI requires the development of an input-output interface matching with human capabilities and the ability to execute a wide range of multimodality and physical tasks. We'd like to break out the level where humans adapt to AI. We have developed a proof of concept for a robot equipped with Tsuzumi, capable of creating a menu with user requests, serving dishes, and expanding the arrangement. We are seeing promising results and plan to continue expanding across various modalities, such as hearing and touch. Okay, that's all from me. We'd like to use our language model to innovate a sustainable future for people and the planet. Thank you for your attention.